Hey guys, welcome back to the Bodhi tree. In the previous video, we saw a few questions related to ratio and proportion. In this video, we are going to look at a few questions for variation. So generally, students find variation to be a bit tougher compared to ratio and proportion, but it is not. We just have to follow two principles, two basic concepts in the topic of variation, that is direct and indirect or inverse, right? Apart from that, as such, there are no other concepts in this topic. So let's directly look into the first question. The reduction in the speed of an engine is directly proportional. All right, so we have direct proportional. Suppose let's say x is directly proportional to y. How do we write this? How do we get rid of the proportionality sign? X is nothing but ky, wherein k is the constant of proportionality, right? Or the proportion constant. Similarly, if x is inversely related to y, in this case xy is equal to k. That's the only difference. This is direct variation, this is inverse variation, right? And now here they have given us that the variation is direct, right? So let me get rid of this. So we have direct variation, and you have to remember that they are saying the reduction in the speed. Okay, not the speed, the reduction in the speed. So the speed might reduce for some reason, we don't know that, but the reduction in the speed of an engine is directly proportional and not the speed. That's the only catch in this statement, right? This is a catch, you have to remember this. To the square of the number of bogies attached to it. What do they mean by this? When we increase the amount of bogies attached to an engine, naturally its speed is going to go down, right? Because the engine now has to pull with the same capacity that engine has, it has to pull more amount of bogies, right? More amount of bogies or the containers, right? The engine has to pull more amount of this bogies now. So what they are saying, so we'll have to assume a few parameters. Let's say, suppose the reduction in the speed is given by r, right? Now what else do we need? So because we need reduction, right, we'll need also the speed of the engine when there's no bogie attached to it. And why do we need that? Because whenever we attach a bogie to the engine, whatever is the number of bogies that we are attaching, square that number, and that is how much the reduction is going to be. That is reduction is going to be directly proportional to that amount, right? B square, right? So B is nothing but the number of bogies. So we have reduction in speed, we have number of bogies. Like I said, we'll need some parameter to justify the speed of the engine without any bogie being attached. You'll see why we need that. But we need that, like I said, because the reduction in speed and not the speed of an engine. So reduction has to be compared to some speed, right? Whenever we attach a bogie to that engine, the speed is going to go down, right? So let's say speed of the engine without any bogie attached to it is x, and speed of the engine when there is a bogie attached to it is s. All right, so we have considered all the parameters. So let's see what are they trying to say, right? No, they are saying something. What are we trying to understand? Let's see that. The reduction in the speed of an engine is directly proportional to the square of the number of bogies. So reduction is r. So it is going to be directly proportional to, let's say the constant is k, directly proportional to the square of the bogies. And this reduction is nothing but the speed, right? This is the speed, and this is the speed of the engine without any bogie being attached to it. Let's assume it to be x0, and this is the speed when there's a bogie attached to it. So basically x0 minus s is this r, right, which is nothing but equal to kb square. All right, now let's see what is being given in the second stage. I understand this might look a bit confusing, but you'll understand, right? If you read this question, try to solve it on your own, you'll understand this is not that tough. We'll need all this because they have said reduction in the speed. That is one of the reasons. The speed of the train is 100 kilometers per hour. So speed as in this is 100 kilometers per hour when there are 4 bogies, right? So when there are 4 bogies, this has to be the same, right? This has to be the same. The engine has some certain capacity, right? It might be some cc, right? The capacity. and it is going to be running at the same speed because that engine doesn't have any bogies attached to it, and hence this x0, 0 as in no bogies, this is going to be the same. This might change because they have said that 100 kilometers when 4 bogies and 55 kilometers when some amount of 5 bogies, right? So the speed is x0 minus 100, that is the reduction, is equal to k into 16, so 16k basically. This is one that is given to us. What is the second condition? This is going to be the same. Now we have the speed as 55 and this is nothing but reduction, which is equal to k into 25k. This is second condition. So we have two statements and we have two unknowns, right? How do we have two unknowns? Let's get rid of this r, right? So we have two unknowns, x0 and k. What is the maximum number of bogies that can be attached to the train so that it can move? Okay, so the train has to move, so the train just has to start moving. You have to understand that. I'll get to that point when we reach to that statement, but as of now solve this. What do we get if I get rid of this x naught, right? Subtract statement 1 from statement 2, right? Equation 1 from equation 2, so I'll get minus 55 plus 100, which is nothing but 45, is equal to 9k. So I get the value of constant is nothing but 5. So with that I'll get the value of x0 as, if I substitute this in 1 or 2 as per your convenience. If you are comfortable with the table of 16, then I'll say substitute in equation 1, 16 5 is 80 plus 100, 180. So the equation that we get is 180 minus the speed, right? The speed at which the engine is moving when there are b bogies attached to it is nothing but 5b square, right? This is the equation that we get. So what is the maximum number of bogies that can be attached to the train so that it can move, right? It can just move, it should just move, right? Just move. So we can say that the engine is moving even when the speed at which that engine is moving is 1, right? 1 kilometers per hour or 0.1 or 0.001 or 0.00001, right? So if the speed of the engine is just above 0, so for our convenience let's assume it is 0, right? It's 0 because even if the speed of the engine when there are bogies attached to it is just about, slightly just above 0, we'll say that the engine is moving and it's able to carry those bogies, right? So let's see, if I put s as 0, let's assume that when we are attaching b number of bogies to that engine, it's stationary, it's not able to move. Let's assume that s is 0, right? So what do we get? 5 3s are 15, 5 6s are is equal to b square. So I get b is equal to 6. So when I am attaching 6 bogies to that engine, what do I get? If I am attaching 6 bogies to that engine, we can say that the engine is stationary, right? Engine is stationary. And like I said, we assume that the speed of the engine is 0, right? That's why I got rid of this s and I equated this to, I got bogie as 6. So I can say that when we have 6 bogies, the engine is not going to move. He's not going to be able to pull 6 bogies. Therefore, we are going to need the number of bogies to be just below 6. And we can't have a decimal number of bogies. Obviously, bogies have to be a whole number. So less than 6, the next number is nothing but 5. So if I have 5 bogies, let's say if I put 180 minus s and substitute b with 5, so I'll get 25 into 5, 125, 125. If I subtract that from 180, I'll get 55, which is what was given to us. For 5 bogies, 55 is the speed, right? But that is not what they are asking. They are asking what is the maximum number of bogies that can be attached to the train. So maximum is 5. The reason being, if I attach 6 bogies, the speed becomes 0. And they have specifically mentioned that it can move, it needs to move, right? If the speed of that engine or the train is 0, will you say that it's moving? Obviously no, it's stationary, right? That was the catch, and that is why we needed this number also, wherein what is the speed of that engine when there are no bogies attached to it, right? Because we have to find the difference, the reduction in the speed and not the speed, right? If it was only about the speed, then we would have not even considered this one, right? No need to consider this, directly consider speed and bogies, right? Speed is directly proportional to bogie square. Alright, so that was the catch, that we had to consider reduction in speed, hence we had to bring in this term, right? The speed of that engine when there are no bogies attached to it. So this question I would say is a bit complicated than the first 3 questions of ratio that we saw, but if you stick to the basics, if you understand the concept, like I said, there are only 2 concepts in variation. Apart from that, you don't have to use anything else. They'll try to confuse you with the statements that are being given, like in this case it was reduction in the speed and not only the speed, right? So you have to take into consideration this kind of subtle changes. Apart from that, variation topic is pretty simple. Let's look at next question for variation. Let us look at the next question of variation. Let's see what is being asked. The heat radiated by a certain body per unit time, okay, they have given the units as well, per unit time, varies directly with the square root, okay. In this case we have square root and not square, right? Remember that, take that into consideration, don't make silly mistakes. Of the excess, again excess, right? In the previous question we had difference, here we have excess, which is one and the same thing, right? We have to take difference. Of the excess of temperature of the body over the ambient temperature. Ambient temperature, that is the surrounding temperature, which is given to be 20 degrees Celsius. Basically what they are saying, heat radiated. So there might be some units for this heat radiated, which is equal to constant under root of some temperature T minus ambient temperature, which is given to be 20 degrees Celsius. So this is going to be constant, right? 20 degrees Celsius, that is what they have given. If I square on the both sides, I get basically h square is equal to k square T minus 20. This is what they have said in the first statement. Let's see what they have said in the next statement. The heat radiated by the body in 1 second is 16 joules, okay. H is 16 in this case, when the temperature of the body is 36 degree. So K, T is equal to 36 minus 20, ambient temperature is 20. We have to find excess of, right? So excess of means by how much is the temperature of the body more than the ambient temperature, excess, more, right? So 36 minus 20, 16, square root of which is 4. So basically what we get is K is equal to 4. We got value of K. Now let's see what is given or what is being asked. Find the temperature of the body when the heat radiated is 20. 20 is equal to 4. Temperature of body is T. Ambient temperature is going to remain the same because that's the surrounding environment temperature. It's not going to change. They have not given us that. 4 5s are, if I square on the both sides, I get 25 is T minus 20. 20 plus 25, 45 is equal to T. So what is the temperature of that body? 45 degrees Celsius. Right? Simple question. I hope you have understood. Again, they have said here varies directly, similar to our bogey question. If I go to that question, right, here they had said that the reduction of the speed is directly proportional to the square of the number of bogies attached to it. Right? Here we had reduction, therefore we took difference, reduction of speed. Even here we have excess, which is nothing but one parameter is going to be subtracted from a similar second parameter. In this case we have two temperature of the body, right, TB, and ambient temperature, TA. We are taking the difference, right, because they have said excess. So excess temperature of this body compared to the ambient temperature, therefore again we are taking difference. Similar question, nothing like in the previous question we were squaring, in this question we are taking a square root. The only thing different is that we had to, here they have given us the ambient temperature, right? Ambient temperature is given as in the temperature with respect to which there is an excess of temperature, right? Excess of the parameter is given. In this case we had to assume that, that the speed of the engine without any bogie, let's assume it to be x naught. This was the catch in this question, right? If we hadn't taken this into consideration, this question would have been more difficult, right? Apart from that, There's nothing difficult in variation topic. Simple topic. There are only two variations, direct and inverse. Only two concepts which are very similar. There's only one difference, right? And we have already seen x directly proportional to y means x is equal to ky. X is inversely proportional to y means xy is equal to k. Right, that's the only difference. I hope you have understood, and you can always ask in the doubts, right? We would appreciate if you ask doubts, if you give your feedback as to what else do you want, or what is required, or what kind of questions do you want us to solve, or which way do you want us to solve the questions. All of this will help us to give you a better content to help you with your exams, right? And you can always join the Telegram group, the description, the link to which is given in the description box, wherein we always constantly interact with the students, give them questions to solve, give them solutions as in how to solve these questions, give them tips and tricks, strategies to solve those particular questions. And like always, please do like this video, share this video, comment on this video, and don't forget to subscribe to this channel. We keep posting this kind of questions on a daily basis, right? If not on a daily basis, at least once in 2 days, because we want you to crack whatever exam that is you are giving, whatever exam that you are giving, and we would like to be a part of that process, the journey, right? So feel free to ask doubts in the comment section.